Instrumental variable regression using STATA. This is our topic. So from where you will get this data and STATA do file, STATA program file. If you go to student resources, Introduction to Econometrics, chapter 12, we are talking about you have data for empirical replication of empirical exercises. You see, you have here data for empirical exercises and test bank. So here we have secret data. You can download secret data from here. Okay, replication files. Download secret data from here. All data sets used in the book are provided here. You see STATA dataset, Excel dataset, and you can use this data and for replication. Another thing which is very important, which I am going to use, that is replication files for empirical results. So here you have chapter 12, demand for secret data, STATA do file. When you will click on this, you will have this do file in front of you. I will use this do file and run this do file. So this will be a short video because I will do most of the things by using this do file. This program is here. So we start with this data and do file. Let's go to STATA. Here we have STATA program. You can go to this data. You can import this data. If it's in Excel, CSV, SPSS, or you can open this data directly if it is STATA data. As I mentioned in one of the videos, that STATA data is DTA. So my data is secret chapter 12, secret data. Okay, you see here I have do file. Here I have do file. Here I have data file, DTA. So I have opened this data. Okay, now this data I have here. You can go to this data browser, data editor, and you have all these things in front of you. Here I have do file. So if you open this, here you have do file. If you open this do file and copy paste the commands which I have shown you from Stock and Watson web page, you can paste it here. You have do file here like I have. So no, one way is that use this do file, these commands. For example, here we are written generate, okay, sort, state, year. One thing is you select it and here run it. So we have sort and state, sort, state, and year. Another is here I have real average price. So you can go to a average price by CPI. Either you can run this command or you can go here, and here you have data, create variable, create new variable. So you see here it's written here generate. So that's why we always write here gen, the first few words. What is your variable name? You can name it whatever you want. RAVGPRS, real average price. So what is this? This is basically AVGPRS divided by consumer price index. Consumer price index is divided to make it a real number. You want to attach a label, you want to put some other condition, you can go it. So if you submit, so you see here you have the full command generate, and we are now going to run these commands from here. So generate is already there. Label it. What's label? We real average price during fiscal year including sales tax. So from now on I am going to run this one. Next you have RTX tax CPI. Again you see, if I submit here, I don't okay, this will remain open. So I can generate next variable, which is R tax over CPI. So we have here R tax. This is tax over CPI. I am going to finish it. I am doing it for those who are learning STATA from the at very early stage. Others can skip all this and run this. Okay, submit. Again, you see this will variable which is generated here. You can label it and all that. Okay, I am not going to do more through this procedure. We have this data file, and now we are going to create all these variables. These are the variables. So here you see underscore n-1 means it's lag of the same variable. So we have data 1985 and 1995. So when we say underscore n-1, it means 1995 minus 1985. So this data are generated, all these variables are created, we don't get error here. Similarly, we are at the moment keeping data only for 1995, as I have done in R file as well. So this is your, I'll show you OLS stage by stage. Go to this variable creation process. Now it's almost complete. No. What we have to do, we'll regress linear model, linear regression. And what is our dependent variable? Real average, basically our dependent variable is, okay, our dependent variable will be, since it's a first stage and price variable is dependent variable, because we want to use price hat, so log of average price, LRVA. And what is our instrument? Our instrument is sales tax. Basically, sales tax. What we have named it R tax SO. This will be our. Okay, submit. Submit. So we have this regression, first stage regression. So we have this first stage regression. Now we'll do, and we have to calculate robust standard errors. So we have to use here robust standard errors. So I am going to, you see, I can write it here and robust standard errors. Second stage is regress. What is our smoking consumption? That is pack per capita consumption. That is my this variable. So I am going to regress it on P hat. I have to regress on P hat. And how will get P hat? Okay. The other way is that we can run it directly, that is statistics, and go to your endogenous covariates, linear regression with endogenous covariates. Here select your variable LR packets consumption per capita, cigarette packets consumption per capita. Independent variable will be the one which is basically just like log income per capita we have used, we have discussed in slides. What is our endogenous variable? Our endogenous variable is price. So endogenous variable is price, log of price. Okay. And what is our instrument? In first case, our instrument is sales tax. Our instrument is sales tax. Okay, R tax SO. No, you can go to submit. You will have, you see here it's written IVREG, so you can give this command and you can run it directly. So this is your basically command for this. Look here, I have run here this one. So this is your endogenous regressor and this is your instrument. If you want to use two instruments, you can use here R tax. So here you have two instruments and you can add more exogenous regressors here. You can add more exogenous regressors here. Per capita income, LPR, okay. Per capita income, submit. So you see you have here instrumental variable single and per capita income. You should use robust standard errors. So we use robust standard errors. Now I am going to do all this through this do file. So this is what is written in this do file, only 1995 data, and you see we have run this one, instrumental variable regression, where log average price is equal to R tax SO, R tax S. What does this mean? That you are using two instruments for one endogenous variable, and log per capita is considered as exogenous regressor. So you have here results, and similarly you can go for differences, and here you have regress OLS and instrumental variables, IVREG you can see here, and first stage. So at first stage we are going to regress log of sales tax as instrument, and we are going to test whether it's a strong instrument or weak instrument. So you see F statistics is greater than 3, so here test DTR tax SO. This is a basically strong instrument. Only difference in this equation and in the above equation that this was only for 1995, and now we are basically taking the gap between 1995 and 1985. You can watch my video number 31 for more details about this data, this problem. And now we regress okay, now in this case I am going to take cigarette specific tax as instrument. So here you have cigarette specific tax as instrument. So here you have general sales tax as an instrument, and we want to see whether this instrument is strong or weak. We have discussed in our previous videos that if statistics is less than 10, we reject it. We think instrument is weak. Here it's 107. Now I am going to take whether both instruments are strong or weak. This is first stage. Okay, test, and what do we get? Okay, variable drop not found. So let's okay, no. What is the case in such a case that we see that instruments are strong? No, whether instruments are exogenous or instruments are endogenous. So from first stage regression, IVREG on both instruments and all exogenous regressors, we get E, residual head. Then we regress this residual head on all exogenous variables, that is instruments and exogenous regressors. And then we test whether these two instruments statistics, they are jointly equal to 0 or not. If they are jointly equal to 0, we say that instruments are exogenous. If they are not zero, we say instruments are endogenous, and then we cannot tell from economic theory that whether instruments are endogenous or not. And this is what which one is endogenous, which one is exogenous. So you see here we have tested all instruments are strong, and this one, last one, basically I think the last one is missed out, that it's chi-square test statistics, but simply I am not describing the theory here. For that you can watch video number 31. I have demonstrated how you can proceed in STATA. Thank you for watching.